It doesn't matter how many are here. But usually this subinterface is for which VLAN service. We enter the corresponding number. The subinterface is now serving VLAN 10. We will enter 10. We now modify its schema. Give it the ability to handle VLAN 10. If there is data coming in from the future subinterface, it will tear down this VLAN 10. If there is data, it will be tagged with VLAN 10. This is what we said before. Then configure the address for it. Its address is the gateway of PC1. PC1 is 1.0. Then we configure its address. 192.168.1.1. 3255 and 10. This is what we call a subinterface. Then go to another interface. Interface Ethernet 00.20. For VLAN 20 service. Still change it to .1Q first. .1Q20. This command makes it capable of processing VLAN 20. The IP address is 192.168.2.1. 3255 and 10. No shutdown. Open the interface. We have now configured the internal interface. Use two subinterface addresses. And the physical interface is opened. It just works. We are now going to engage in the external network interface. E01 interface. Interface E01. Then configure the address. IP address 10.0.1.1. Followed by a mask of 30 bits. 255.255.255.252. No shutdown. Open this interface. Then we need to configure the interfaces of R1, R2, R3, R4. I configured it in advance. But I don't know if it is configured correctly. Let's take a look together. On R1 this. Show IP interface brief. Let's check. Avoid configuration failure for a while. I just take a look at each one. Move on to the next device. Show IP interface brief. This is right. Then R3. I will not demonstrate the interface address to you in class. This is what I have already configured in advance. There's nothing to say about this. Just configure one by one. Last R4. It's okay. Now the internet address is configured. I have also used the loopback port addresses on R1 and R2. So what are we going to do now? Look. PC1 has not done automatic address acquisition. We did not manually configure the address of PC2. We just let the VLANs PC1 and PC2 belong to be divided on the switch. Then the switch is configured with the gateway. Configured the section about one-arm routing. Interconnected interfaces are configured with. Then the internet routing of the external network is configured. Then let's start configuring one by one. Let's let this PC1 get a fixed IP address forever. 192.168.1.11. Show IP. We can see the MAC. Then we need to copy this MAC here. Then to the gateway. Because we want to configure the gateway as a DHCP server. IP DHCP pool. We define an address pool. Suppose this address is called P1. We are now going to assign an address to a single host. Then I just enter host here. Because I only configure for one host now. Configuration address. 192.168.1.11. 24-bit mask. After adding a fixed IP and mask, set up the corresponding gateway. Gateway is 192.168.1.1. Because they have to be 1.0 network segment. So it belongs to VLAN 10. After that set DNS. DNS server. 114.114.114.114. OK. We are now done setting up DNS. After setting, we are about to bind the address. Client identifier. I'm going to tether the MAC now. I just finished copying the MAC. Paste it right now. We can't just press enter. To add 01 at the front. 01 stands for Ethernet. After that, it must be separated by 4 digits in the form of a decimal point. Then press enter. Now for a MAC address like this. I configured it with a fixed IP address. Gateway gave it. DNS gives it. It itself is a DNS server. It now only needs to open the DNS service request on the PC. So we come to PC1 here. IP DHCP. Then press enter. Start sending out messages. Now if you get the address. It is the address of 192.168.1.11. Gateway is 192.168.1.1. Then PC1 is configured. We now manually configure the address for PC2. 192.168.2.2. 24-bit mask. Gateway is 192.168.2.1. It is now configured. I now ask you a question. If now PC1 ping PC2, can you get through? 192.168.1.11 ping 192.168.2.2. It worked. Let's review the whole process. How is the single ARM achieved? PC1 is the address of 1.11. PC2 is the address of 2.2. Cross-network segment access to find a gateway. The gateway is the subinterface of E00.10. 192.168.1.1. Come in interface. Then in the process of coming in, I will put VLAN tag 10 on this interface. When this interface is released, enter the subinterface 00.10 with tag 10. Because it strips the VLAN tag on the incoming interface of VLAN 10. So it will carry an empty label into the router. The router looks at you to go to 2.2. We'll see if there is a local route to go here. There is a direct connection. Come out from its 0.20 interface. Then when the data empty label wants to leave the 0.20 subinterface, it will mark this data with VLAN tag 20. Keep going down. Reserve the mark through this trunk. Then when passing through the access interface, strip off VLAN 20. Then a blank data frame is sent to PC2. The two of them will pass. This is one ARM routing. VLAN layer 3 communication. This is the VLAN we talked about earlier. We're going to do PAT now. In fact, we just finished talking about this. We first match the traffic of the PC. Because 1 is in the 1.0 network segment. 1 is the 2.0 network segment. So we simply match all. Anyway, it is also the host of the intranet. I want them online now. Permit any. IP NAT inside source. This is the fixed configuration format. Must remember. List 10. Associated with this anti-control list. Interface Ethernet 01. Then overload. Port multiplexing. The two ports have not been configured. First enter the E01 interface. It is IP NAT outside. I'm stuck in this link for a while. I think it might be a mirroring problem. Wait a while. In the process of waiting, let's analyze the configuration we will do next. We will then declare OSPF on the 4 devices. After the declaration is over, we can communicate with each other. How can we test that PC1 can access the internet? PC1 can access R1. It can go online. So wait a minute, we're going to do this 1.1. Telnet back and forth. Including PC access 2.2 where to go. In fact, I tell you this. For PC traffic may not be able to see where it goes. But we can. Let R1 use this 1.1 as a simulated flow.